wanted to ask Anthony, currying is a functional programming topic. What is it that made you make this challenge? Do you remember? It was a while ago.
This is probably one of the reason I started to have the type challenge project. I don't use functional programming that much myself, but it's actually asked by one of my colleagues, and at that time we were just having a group and we were trying to solve the problem like our colleague had, and one of and my another colleague is that he's also good at TypeScript. So we were having people asking these questions, like how I can do this way so I can have a currying function, something like that. And then we're starting to thinking, yeah, maybe we can try that. And then me and my other colleague, we starting to compete with each other to say who solved this problem first. And then it's quite fun. So I think this is probably can be a project that can collect many different kind of questions. So that's how the type challenge is born. And yes, so I don't use it myself, but it's fun to implement it.
That's a great story. Yeah, I love that. I also, I love functional programming. I always have, and being able to do these kinds of things is really cool skill to know. So, So for anyone who's not familiar, currying, it's named after. Do you know where the name comes from? It has nothing to do with the food. It's by this. There's this guy. He's a mathematician called. This was his name, Haskell Curry.
Yeah, his name. Yeah.
So yeah, a lot of people see currying and think it has to do with curry, which it doesn't. It's just his name, and his first name was also got the name of a programming language. So
yeah.
So basically, we define a function that takes any number of arguments, and we want to be able to call it. So we want to be able to say, like, let's just take the example of curried1. We want to be able to say, so we have a number and true. So this is a way of calling curry. Okay, let's see. We got to put it below probably. Is of type unknown. Did I spell it wrong? Currying. Well, in any case, what currying is in general, let's just name this X, is that instead of being forced to just call this as you see here, you could also call it with just the first two things and then pass the third one along, or you could call it with all three of them separate. Let me write that in. Okay. Oops. There we go. So this is or any combination of these three. So this is a kind of a technique for writing functions that are partially applicable. You don't have all of the arguments yet. In Haskell, actually, all functions are like this by default. So if you define a function with 3 arguments and you only call it with 2, what you get back in this case is a function that's it's waiting for the remaining variable. And you don't have to do anything in Haskell for that to work. It just all functions work that way all the time, which is kind of interesting.
Mm-hmm.
So the task here is to implement this individually. So we're not doing all combinations, but we're doing like splitting up each individual argument into its own little thing here. So let me see if I can work through an explanation. It's especially unfair to even ask you to do it if this isn't something you do. So we have this function. Let's give it a type. So let's put it fn there or something. There we go. And what we can do is we can make it an extends block here. So we can say function extends, and then we have to kind of fill this in.
Yep.
And we can infer the arguments from there, and we can infer the return type as well. So we have our true and our false. From there, we're going to check to see if args is empty. If args is empty, then that's fine. We don't have anything else to do. We can just return a function like an empty function, that's what this case is here, B3. But if args does have values, then we'll make a helper type. we'll keep the return and we'll pass in the args. And in this case, I guess we'll have never here. I guess we could put in a constraint here. Extends function is fine. So let's make our helper. In this case, we have args extends unknown array because we don't know what the values are going to be. Like in the example we saw up top, it's like string or number or Boolean. So there could be anything inside, any TypeScript valid type inside here. So we type it as unknown. And we need the return type as well. Okay. So from here, we're going to do a lot of the types, the challenges, Anthony, they start this way where we have like this infer head, infer tail approach. And then we have the base case of recursion usually is easy to think about. The base case of recursion is we just return the return type. But if we have more arguments, then we're going to have a function that we return. The function has the first argument, and then we're going to curry in the rest. Oops, not response time or tail.
Tail.
Yeah.
Yep. That's it.
So, this is kind of the place where it recurses. There's not really any recursion in the declaring of the function, but it happens more here. And if we have more arguments, then we'll keep going. But if we don't have more arguments, then we will just hit our base case of recursion, in which case the return type itself won't trigger, and this block, and we'll be done. Because tail will eventually be an empty tuple. An empty tuple will not match this because it doesn't have a value. So then we just return R, and this becomes R. Yeah. Anyway, is it anything like you remember? I don't remember what it was like. What solutions were like at the time you solved it, because I think this third case didn't exist at the time that this challenge was created, and this case makes it harder.
Yeah, at the time we solve this, like we are trying to solve these challenges that we don't have the way to spread the infer. So you don't have the infer head, infer tail. Instead, you don't have this function so convenient. So basically means we will have a pop and head, tail, something like that, and utility type to do that.
Yeah,
it's way easier now.
It's much easier now. Yes. I'll show you a couple. So I have a couple alternatives that I found for this. Here's one. I try really hard to credit people, but when I see a lot of people with the same solution, then it's hard to know who came up with it. But this one just checks that T extends a function, and if it does, then we pass in this, through our helper. This is kind of an interesting technique. You can check the parameters at the beginning and then see that they extend some array, and you can grab like first, second. You could grab as many things as you want and then bundle up the rest.
Yeah.
So this is very similar to what we did with up top from here. We have first head and then we have curry, but what we pass in is a function containing this second item as an element in an array.
Yeah.
So instead of passing the return type and the parameters separately, this one passes the whole function as T, and then we grab parameters and we grab the return type using these helpers these are built-ins.
Yeah, this is probably not the best, the most efficient way to do that, but it's interesting.
Yeah, I don't think so either. It's definitely a little confusing too how we grab the first two. I like the first solution better, but I think it's interesting to show like what you can do with. There's very powerful, and then I have two more. This one by Diamond Mofang on GitHub. So it's kind of cool because there's almost nothing going on for the currying part. We have our helper. And of course, the helper gets the function instead of just splitting up the arguments, because it does the work here. So you can do an infer statement inside the arguments of a function, which is also very weird. I don't see this a lot, and I don't think a lot of people know you can do this. But you can infer right from inside of a function literal. This, what I have highlighted on the screen, is a function literal.
Okay.
So then they check if there's
residency.
You see?
Yeah.
Yeah. What do you think about this one? Do you like it
It's
better,
not
or
bad,
do
but
you like the first one?
Um, I think I can do that more concise.
You want to? Okay. What would you do
Sure, let me
differently?
try.
More
Okay.
concise than this first one?
Yeah, probably. I'm not sure. Oh, I can try.
Okay.
Okay, I'm doing at the button.
Okay. Yeah.
Okay.
Let's. I'll comment everything else out.
Okay. So basically means that currently we have this one, right? So without this one, so like initially we have this, right?
Mm-hmm.
And that is that you can have the so is that instead of having the function inside the generic, you can have a
Mm-hmm. And I'm gonna don't be bothered. I'm gonna wrap you onto the next line because I have to fit it on the screen.
okay,
But okay.
and then we will have a return type extend. You don't need to extend anything, so means that you return it.
Mm-hmm.
But then you have those two things, right? Okay, is that good? Maybe I should have a bracket here. Not sure.
Mm-hmm.
I'm not sure if the TypeScript is enabled on my side. It does. So you can have the curly one, and then you have a parameter and return, and then we have the type, and then the probably just the same as you do for
Mm-hmm.
the utilities. Let's again over.
Yep.
Yeah, and then they probably do right.
Okay. Cool. Setting up the helper type. Mm-hmm. Okay. Grabbing the head and tail.
Yeah, and then so you do like this, right?
Yeah. Just to fit it. We have a little weird formatting just to fit it on the screen.
Yeah, and then you just have a curly and then you have the return exit. Does that work?
So I think the API is a little different. Let's see. Would this work?
Or I'm missing one
And
special case.
it seems like it works. What is the return? Oh, interesting. The return type is
Oh, it actually becomes more strict, right?
yeah. It's interesting that the return type is not being picked
The
up
return
as
type is being inferred. Oh, I
string
don't
number
know.
boolean. So that much is true. So if we said boolean, then this would be right. That's really interesting. I don't know why that happens. Why it's not working.
No,
Interesting. We can do.
interesting.
I think if we're not in TypeScript 5. If we were in TypeScript 5, we could do. We could say const here, and do a const generic. I think, and then maybe it would work. But that's very interesting. So
I'm not
this is
sure.
definitely very concise. But there's something about how, like, if I put a 1
How
here,
TypeScript handling
yeah.
the
So Curry,
the
yeah,
type writing
it
thing.
returns number instead. So if I put number here and I
Interesting.
put number here on line 15, did I say it right? Oh, if I put 1 there and then number there, okay, yeah, then it passes. Very interesting. I don't know why that, I can't
Yeah,
explain why that
probably
happens.
you can figure out a way to do that, but it's yeah.
Yeah. Wow. That was really cool though. I really loved watching you do that, and this is a good solution. So if anybody watching below understands why that doesn't work, why this solution here doesn't work, please let us know. I had one more. That was great. I had one more to show. This is it. This is what this is what the challenges used to look like. A lot of the solutions of the older solutions that are up on GitHub don't work. And because the reason they don't work is there's this A3 example that takes an empty, that has a function with no arguments. So this fails for that case because it doesn't handle that. But I just thought it was kind of interesting to show the kind of history of it. If you pause your screen now, if you want to take a longer look at how this actually works and understand, it'd be a good challenge to try to upgrade this type to support single array or empty array, meaning empty tuple, no arguments for the function. But yeah, anyway, we can move on. But that was cool. That was fun.
Yep.
Awesome.
Yeah.